Character animation is one of the fundamental skills every game creator should understand. Whether you are building an intense action game or a cinematic experience, how your characters move can make or break your immersion. In Unreal Engine, mastering the basics of animation doesn't just bring characters to life. It gives your project the polish and professionalism that the players and viewers expect. Even if you are not aiming to become a full-time animator, knowing how to work with character animations will unlock new possibilities. It's a core skill that can set you apart in both gaming industry and film industries. While Unreal now offers powerful systems like the motion mashing and the animation locomotion system ALS for incredible realistic results, they can be tough to grasp if you are just starting out. State machines, on the other hand, are simple, effective, and a great way to get your project moving quickly. In this video, we'll build a third-person template, cover the basics of animations, and create our first animation blueprint. But before we jump in, make sure to subscribe and turn on notifications so you don't miss out on more Unreal Engine tips, free assets, and pro-level game development insights to help you build stunning projects and grow your career in the gaming industry. Now, let's get started. The first step will be creating a project for a third-person game. I will select the starter content, of course will be a blueprint, and this is the name that I will assign. In my case, I'm using Unreal 5.5. Once the project is created, go to the folder called Third Person, inside Blueprints, and open the BP Third Person Blueprint. This is the character that you use to play the game. Go to Viewport, and here it's the character. Selecting BP Third Person Character in the components and going into the details, you'll find this section called the Mesh. Inside is the Skeletal Mesh asset. I want to find this skeletal mesh, so I click on this button. You will be redirected to the corresponding folder where these meshes appear. Open the Skeletal Mesh. In the Skeletal Mesh, the SKM Queen Simple, let's check this button to the top right. The first one is the skeleton. When you select this skeleton, you can pick any bone of this character and you will see where it is located. If you want to hide some of the bones, select Character, Bones, and let's say select the Selected Only. That will present only the bone that I pick here to the left. I like to work with all bones so I can have more control. Let's say that I want to move this left arm. I can select this bone and I can move the arm of the character. The importance of the denomination of these bones is related to the retargeting factor. Let's say that you have other animations that you want to retarget for this character. Then there has to be some relation between the names of the bones that we assign here from the source of this animation. The second button is the Skeletal Mesh Editor. This is used to modify the skeletal mesh that is linked to the skeleton. And that way you can define how the character is going to look, how it's going to be visually presented. This functionality is where we are going to fix elements that doesn't look good in the final animation. Sometimes when we retarget, some of the proportions are not working. That is the type of cases where we are going to check the Skeletal Mesh Editor and make some changes. The next button is the Animation Editor. When you want to watch the animations of your character, you have to pick this button. Let me get a bit closer. And let's close the bones. I don't want anyone selected. You can see at this moment that this character has animation. It is an idle animation. You can also select other, let's say landing. Oh, sorry, I select Run Forward. Like this one, you can check all the animations that you will be not only have in this project, like this one, but also some others that you can import from other sources. Just double click the animation you want to see. Let's say this walk forward, and you'll check that everything looks correctly. Continue with the buttons. We have the Blueprint Editor. We use this space to define how the animation of this character is going to behave. Inside we have the event graph that runs the events. and the animation graph where we control the states of this character. Depending on the state, let's say that you are moving forward, you're going to define let's run, let's play the animation of running or walking or jumping, depending on the actions that the gamer is asking for. And the last button is the physics asset editor. It is similar to the skeletal mesh because they have the same structure. Well, not exactly the same structure, a similar structure as a skeletal, but we are dividing sections of the body of this character to define that this is going to be how physically this is going to behave. For example, when we're talking about collisions, you can create a character that is an entire object, or you can create a character where you have different sections that can collide. When it is presented like the case here on the screen, you will be more precise at the moment of identifying different types of collisions. This section, for example, refers to the hand. This refers to the head, legs, and etc. The fact that these elements are linked to the bones is essential because let's say that you are trying to pass through a space where you have to dock and move. In that case, all these colliders, all this physics will move with you and reduce the space to create the sensation that you are not colliding with, let's say, the roof. I wish to go back to the animations and let you know that all these files are animation sequences. They are called like that because they are executed in time. In fact, once you click one animation here, you can stop it and you can see the entire animation as it is played through time. There is another type of animation which is not the sequence, and it is called the blend space. And the blend space is an asset that allows you to blend different types of animations based on one or two parameter values. You can identify them to the right because they have this kind of, I don't know how to mention this color. It looks like a clean red or clean orange or maybe a yellow. Let's click this one named BSMF on ARM walk run. Now, the first thing is that you don't see parameters in terms of sequence for time. What you see is a parameter on the bottom linked to the speed of this character. At this moment, this speed, this parameter is 0. From the animation, you can see that the character is kind of warming up, but it is not moving forward. Now, if you use Control and move the mouse and increase the speed, look that this X is increasing the speed, the character will start moving at that particular speed and create the effect of the animation for that speed, even if we get to 500, which for this character is the max speed. Essential knowledge like mastering animations with state machines is what moves projects forward. In the gaming industry, progress is key. It's not just about finishing a project, it's about constantly learning and showcasing that growth. Whether you're building your own business or seeking job opportunities, what matters is your ability to demonstrate continuous improvement. The Game Creator Accelerator is here to guide you with a lifetime access mentorship using a proven methodology designed for your success in the gaming industry. Reach out to me at tony@woolun.com or schedule a time to chat using the link in the description. Let's start creating your future in video games the right way. Let's close all these tabs. I will add a new folder. I always do this, which is a reference for the folders I'm going to create that are not part by default of the project. _game is my usual name. Right click and create another called animations. In this step, we're going to create a blueprint animation. On the folder I just added, right click, look for animation, and select animation blueprint. You will be prompted with this image indicating that you have to pick a skeleton. In my case, I will select the SK mannequin, which is the default skeleton that it is presented with this template. And then create. Because this is an animation blueprint, I like to start in the name, calling it by animation blueprint. Let's call this character. Double click to open your blueprint. As soon as you open this blueprint, you have two graphs to work with. By default, it is open the Anim graph. The event graph is similar to any other that you work on blueprints in general for Unreal. The Anim graph is where we create these state machines and we use new nodes to play sequence animations or Blendspaces. Open the event graph, and here you have the blueprint update animation, which is, imagine that is the update, the element that will be constantly refreshing, and the other is the try get pawn owner. The pawn owner allows us to have control of the pawn that is using this animation. In case that you need to do some initialization, then you can look for the event blueprint initialize animation. In the section of my blueprint, let's add some variable. Let's call this variable speed. It will be of the type float, and we're going to use it to define some behavior for this animation. As the way that we should proceed always when we are working with objects in this programming in Unreal, I have to check that the object is valid first. So from the get pawn owner, I'm going to drag a wire and connect with isValid node. Pick the isValid and connect it with the event blueprint update animation. From the pawn owner, I'm also going to drag another wire to get velocity. And from the vector of get velocity, I will obtain the length. Vector length. And this vector length will be assigned to the value of speed. So drag speed here, set, connect this, and from the isValid to the set. What we're saying here is that from the pawn owner of this blueprint animation, we're going to get the velocity, obtain the length of that vector, and assigning the value to the new variable we created called speed. To complete this process, compile and save. You see that an animation starts like running here. That means that the value of speed will be updated constantly. Now we can use this variable in the Anim graph. The Anim graph can only access variables from the animation blueprint, so we use the event graph to get the updated values from the pawn. The node you find in the screen, which is named the output pose, is the final animation, the final pose to be presented using the skeletal mesh. In the asset browser, let's find an animation related to run, which is this one, MF run forward. Drag it to the Anim graph and connect it to the result. To watch the result in animation, compile, and here to the left you have the animation running. If the animation stops, it's because the loop is not enabled. So click on the animation and on the right on details, look for the loop animation. Click, compile, and now the animation is looping. But now let's say that you don't want to run a sequence, but to control a blend space and use the variable that you created with speed. Let's move this one to one side and remove this connection. Look for the blend space, which is named BSMF on ARM walk run, and drag it to the Anim graph. Connect the nodes, and if you compile at this moment, you see that the velocity, the speed is 0, so the character is not moving, it's static. Now let's drag the speed with get and connect this variable to this one. Compile and save. By default, the speed is 0, so nothing is happening. But as we increase the speed, then the animation will look like the character is moving forward. Let's modify this variable on the Anim preview editor. Let's set the speed to 20. Now you can see that the character is kind of starting and moving. Look at the steps. Let's increase to, I think that the maximum was 500. And now you can see the animation for the maximum speed. Another for 200. And let's say another for 50. It looks like an old lady. Let's remove these elements. The goal is that now we start working with state machines. The state machines in the Anim graph allows you to organize the animations in groups of states. For this example, we're going to start using two states, idle and moving. Then we need to define what will be the transition rules between these states. Right-click on the Anim graph and look for State Machine. And pick the one that says State Machine. And the name will be Character States. Double-click on the Character States. Let's compile so we stop this animation. Now I need to add two states. Look that in the order we are in the blueprint Anim graph character states. If you want to go back to the Anim graph, click here. If you want to open the character state, double-click and now you are inside the character states. Right-click and select Add a State. Name the first state Idle and connect the entry to the idle. Create another state called Moving and make a connection from the idle to the moving and another connection from the moving to the idle. The idle state and the moving state will have their own animations. Now I want to get into the idle state. Double-click over it and look that now we, following the sequence, are in ABP Anim graph character states state idle. To the right, bottom right in Asset Browser, let's look for idle animation. I will pick the MF idle animation. Drag it to the map and now connect this sequence with the result of the output animation pose. Now let's follow the sequence. A moment ago, we defined the idle state when the Anim graph starts. The idle state has their own animation, which in this case is the MF idle. And this will be presented on the output for that idle state. So when we play the idle state, this is the animation that will run. The next step is working on the other state. Go to Character States, double-click the moving. Now let's look for run animations. But instead of using a sequence, we will use a blend space. In this case, I will use, I think, this one. Connect to the result and look for the parameter speed, get, and connect with speed. What rest is specify the transition rules. Go back to the character state, and here you have the connections from idle to moving and from moving to idle. And if you double-click, you can see the result that will define the transition. In our case, we will use the speed parameter. And we're going to compare the speed parameter with some value. Let's say that speed parameter is greater than 5. If it's greater than 5, then I want this transition to happen. And to go back from moving to idle, I'll click this transition, double-click, and we do something similar. Just that in this case, will be less than 5. Compile, save. Connect the state machine to the output bus. Compile and save. The character is starting to move because the speed is 50. Now let's say that the speed is 4. If the speed is 4, character stops. If the speed is, let's say, 500, it's going to be running. This is the magic of changing states using the state machine in Unreal. Let's put it back on 0. So far, we presented how to create this state machine, how to create these blueprints in Unreal. But let's close this for a second and go back to our original project where we have this character that is the one we used to play the game. Open the blueprint, and in the blueprint, in details, look for animation. And here's a parameter called Anim class that points to the animation blueprints that will control this character. In fact, the entire order will be in the world setting, you have the game mode, and if you open the game mode, you will find the default pawn class, which is the class you use to play this game. If you go to the default pawn class, you will find this blueprint, which is the one that is the character that we used to play at this moment. And if we open this blueprint, you can find then the animation class that controls the animation of this character. The information that these characters provide in terms of the movement will give the animation blueprints the inputs to take decisions and present different kinds of animations. Now let's go and open the animation. This is the animation for the ABP Queen. If we open the ABP Queen, you will see that we only have the event graph. We don't have an Anim graph. And the reason is simple. When you don't have the Anim graph here on my blueprint, go to the class and you will find that it is a child of a parent class, in this case, ABP Money. Back to the project, here is the ABP Money. Open the ABP Money, which is the parent class of the ABP Queen, and inside this blueprint, then you have the event graph and the Anim graph. And similar to the exercise we did a moment ago, you have the locomotion state that changes between the idle and the walk and run. You might remember as well that this animation of this character for the template of Epic Games, it just don't run, it also jumps, fall, etc. You can go back to the main states. In fact, you can go back in order to the Anim graph. And this is another kind of states that you can handle with this blueprint animation. Here you have the locomotion, which is related to the same locomotion I just presented a second ago. But then we have also land, fall, loop, and jump. If you want to see how this is working in your game when it is assigned to a player, play the game directly in the animation blueprint and then pick in the preview instance the ABP Queen, which is the character playing the game. Now, as I move, you will see how everything changes live. Look at the jump, look the falling, and if I don't jump, just fall, go from to falling to fall. Please share in the comments what kind of games you are trying to create and what your animation challenges are. And be sure to check out the next video on why game developers fail and 3 right strategies. If this video added value to you, like, subscribe, and ring the bell so you never miss tips and tutorials on Unreal Engine and how to build your successful career in video games. Until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.